Baseball is the greatest game on earth.
But we, your four trusty announcers, are here to tell you about what makes the game so great. I'm Kayla.
I'm Erica.
I'm Jenny.
And I'm Sammy.
Let's get started! The game starts with the first pitch.
He pitched the ball at 98 miles per hour. What a high speed!
It must be because he's so strong.
The reason the pitcher's arm keeps moving after the ball is released is because of inertia. Inertia is an object's, or in this case, his arm's resistance to stop motion.
After such a good pitch, she's gonna hit a homer.
Here comes the strongest girl on the team. Because she is so strong, she can exert so much force, causing the ball to go the farthest. However, she's also the heaviest, making her the slowest.
Wow, that sounds a lot like Newton's second law. Force is directly proportional to acceleration. Mass is inversely proportional to acceleration.
The bat drops so much more quickly than the ball.
Let's get an instant replay of that hit. After such a major application of force, the equal reaction of the bat pushing backwards is just as major. This makes sense because of Newton's third law. For every force, there is an equal and opposite reaction.
So much force allowed the ball to be hit so high up. Good thing the force of gravity pulled it down, allowing the player to catch it.
Wait, what is a force?
It's a push-or-pull.
Wow, she hit the ball so far and now has to speed up to first base. What a great example of acceleration.
He caught the ball, creating an unbalanced force. Newton's first law says that an object in motion stays in motion unless acted upon by an unbalanced force. The ball would have remained in motion if it was not for the hand acting as an unbalanced force.
The ball is speeding up when it comes down because the force of gravity pulls it, and the ball decelerates as it goes up. The player is running to a base, and it looks like he slowed down for a second. It's because she's changing direction. Changing direction is a type of acceleration.
When a player is running between bases, the player uses their cleats to push onto the ground, while the normal force from the ground pushes the cleats back up. Rubber on dirt has a high coefficient of friction. They stick together well, which is why rubber is the chosen material for the surface of the shoe.
So why are there spikes on the bottom of the shoe?
The spikes add to the needed traction on the bottom to create more friction, preventing the player from slipping. Sand and grass are both slippery surfaces, so the cleats help the player stay upright and focused on the game rather than their balance. He slid on the dirt and stopped right on the base. Thank God for friction working against the applied force that was pushing her forward.
While Erica is busy sliding on the bases, we will tell you how to calculate force, mass, and acceleration. To find force, multiply an object's mass by an object's acceleration.
To find mass, divide an object's force by its acceleration.
To find acceleration, divide an object's mass by force. To put it in simple terms, the formula is F equals ma. I just love baseball.
And knowing the physics of it just makes it so much
How
more.
do you find the friction force?
Multiply the mass of the object by the coefficient of friction between the two materials.
That was such a great game of baseball.
We should play again.
How about right now?